Good evening to everyone. Now I am discussing about master slave flip-flop. First we will see clock. This was the clock signal here I am giving. This was the clock 1, clock 2. Here I am giving clock signal either low or high. What will happen? Now I am giving in clock 0. Then clock 0 clock is inverted into clock 1. So here I am giving 0 means it will inverted into clock 1. Again this here again connected to inverter, this will again inverted into clock 1. So this is clock 1 is the inverted of clock signal. This was the clock signal, this is the inverted signal of clock 2. This clock 2 clock are same. This is the circuit diagram of master slave flip-flop. Here I connected two pass transistor. Here T1 pass transistor and T2 pass transistor, and also I can use two memories, memory 1 and memory 2. Here we are giving the input signal either low or high. What will happen, let will see that operation part. This is the operation of the master slave flip-flop. Here I am giving clock signal low. This clock signal represented as a low signal. While I am giving clock low, the T1 pass transistor is on, the T2 pass transistor is off. Why? This is all of us know. This is the PMOS transistor. This was the NMOS transistor. Here this one I am giving to clock 2 signal. Here clock 1. While I am giving clock as a low signal, that clock 1 inverted into high means it's 1. Clock 2 again inverted into low. So PMOS transistor low means it will on condition. Clock 1 high, it was the NMOS transistor. NMOS transistor is high means it will also on condition. So the total TMOS transistor is on. So why T2 is off condition means clock 2 means low. Here we are connected in NMOS. So NMOS transistor low means it will off condition. That clock 1, it was the NMOS transistor. Here high means that NMOS transistor is off condition. So totally the T2 pass transistor is off condition. So let me see the truth table. Here I am giving low signal. The T1 pass transistor is on, the T2 pass transistor is off. Nodes. Here we'll see A, B, C, D. This was the nodes. This was the value. Here I am giving input signal AI. That here AI. B also will get this was on the input signal enter into here. It's also AI. Why the CI node is inverted means whenever we are giving the input signal, the T1 pass transistor is on condition, it will enter into the memory. Here we'll see the memory. It will move to the right side if the pass transistor is in on condition. The memory will inverted the value. So the AI was inverted into AI complement. That DE, this T2 pass transistor is off condition, that's why we are not get any value. So my desired input is 0 means low. I have moved from 1 to 0. So initially it was 1. This 1 is here because clock is low. The pass transistor is moved to the right side. This was on, that's why it moves to the right side. And one bar which is 0 is moved to this node. The main node C1 or CMOS, here it has successfully now You are at 0 here, it has not successfully. Now you are at the 0 at C master till this point. So this pass transistor is on. One will discharge this capacitor completely to 0 volts. Whether you give to 0 to this inverter will charge completely to 1. So all fine here up to here. Next we'll see the transistor move 0 to 1, what will happen. Here I am giving clock signal high means 1. The transition from 1 to 0 I am doing exactly when clock is also changing. So what I will happen at this time, clock is trending towards off condition. Why it's off condition? The clock 1 is low. Clock 1 already we know that here it's connected in NMOS. NMOS low means it will off condition. Here I am giving high. Clock 2 means this was the PMOS transistor. PMOS transistor high means this one is also off. So totally this one, the T1 POS transistor is in off condition. We'll check T2. Here I am giving clock 2 as a high. Clock 2 high means here I am connected in NMOS transistor. So NMOS high means it will on. Here low signal clock 1. So the PMOS transistor also on. So totally the T2 pass transistor is in on condition. When clock is transition to 1, what is happening to pass transistor T1? When it is trending towards off the clock. So whether the clock is going from 0 to 1, the pass transistor is trying to get off. Before the clock is rising to 1, before this value is switch off. So only some voltage is moved here. It is not able to discharge entire 0. Discharge into 0 means from 1.8 volts you need to get 0 because your clock went time and you do not have enough time. It has discharged only 2.9. If we are giving clock high means T1 pass transistor is off condition, T2 is on condition. Notes already we know that this was the A, B, C, D, E. Any value. This was the off condition. Here whatever will get that value. B also whatever will give that input signal only. C it's a complemented signal. This was the on condition. That's why here D will inverted. That inverted value as a T1 pass transistor output. E that here we've inverted the value. Again this inverter inverted that value. So we'll get only whatever will give the input, that value only will get here. A1, AI. Metastability. Here 0 to 0.2 we are considered as a logic 0. 1.6 to 1.8 we are considered as a logic 1. In between the value logic 0 to logic 1, in between the value we are giving to the inverter that as a high impedance state. That value the inverter will not recognize. After some time another inverter is there. This was oscillate. After some time it will go either 0 or 1. This state is the metastability. The inverter was not recognized that value either 0 or 1. That state was the metastability. Here we will see this is the clock signal. Data changed in the setup. The output of the flip-flop. Here see, observe, this was the metastability state. Here you'll observe that signal is either 0 or 1. It will not recognize that state as a metastability. Setup time. This is the clock. Will give the input. Before rising edge of the clock, the data should be stable is called a setup time. Here we are giving clock signal before rising edge of the signal, that was a stable. We are giving that clock signal. Here the capacitor either fully charged or fully discharged, that we are giving to the inverter. The inverter will recognize that value is called as a setup time. See, this was the clock signal. Here before rising edge of the clock, this was the setup time. Here will indicate this one. This was the signal. This was the signal. Here that clock before rising edge of the clock. This will indicate it as a setup time. Clock active edge. This is the hold time. Clock active edge data, whatever we in. The definition of hold time means after rising edge of the clock, the data should be stable is called as a hold time. We know that setup time before rising edge is called as a setup time. After rising edge is called as a hold time. When the clock is high, that clock 2 is low. After two propagation delay, it will stable. Here we'll observe after rising edge of the clock. After rising, it will stable. See, after rising, this was the rising edge. After rising edge of the clock, the input should be stable. Here, the input should be stable. This is called as a hold time. Timing diagram of setup and hold time. This was the clock signal. This was the setup time means setup violation, hold violation. Setup means before rising edge of the clock should be stable. Hold means after rising edge of the clock data should be stable. Here also, this is the setup, this is the hold. Here rising, before rising setup, after rising is called as a hold. This was the timing diagram of setup and hold time. Thank you.